Uh, Hello all. Am I audible?
Yeah, sir, you're audible now. You're audible now.
I'm audible now.
Yeah, yeah, perfect now. It is audible, sir.
Okay.
You can continue.
Okay. Okay. Okay.
Yes, sir. Thank you.
Sorry for the initial trouble. Good morning. Good afternoon, everybody. Thanks for this wonderful introduction. And good morning, friends. Welcome to the webinar on factory automation and Industry 4.0. I would thank to extend my regards to Department of Electronic and Instrumentation and all the faculties who facilitate this session so we can interact. Uh, let me share my presentation first. Yeah, my screen is visible, right? If you can, somebody say yes in the message box, it will be fine. Can you all see my screen?
Yes, sir. Your screen visible, sir.
Yeah, yeah, okay, thank you. Thank you. So, yeah, so today it's so exactly a decade back, I was in college third year and I was wondering whether to how to join a corporate and industry and make use of what I have learned in my college. And I think students here are in the more or likely same position which I was a decade back. So I would like to share technical knowledge along with my own experience, how I feel uh, a transition from college to industry. And in the way I think we'll be touching a lot of vast range of topics. The spread of the session will be how the industry has gotten so far till now and where it poised to go, and then we'll be touching what are the skills required till now to work and future skills which the student should be acquiring to propel the industry towards 4.0 and further advancement. So, without further ado, I'd like to start with my first presentation, and we'll try to keep this session as two-way communication. If you have any doubt, please raise your hands or you just type in the message. I will definitely at the end of the session will try to make sure your all doubts is clear, right? Okay, so let's start with some little bit here on historical note. As you can see, the evolution of manufacturing industry from first mechanical and steam-powered machines to now a very complex amount of robotics, as we all know. So, but the transition was spread over more than 150 years, and as you can see, the second industrial revolution is actual happened with the advent of electrical energy available in the mass production. And perfect example of this is Ford Model T production. You can see the image there. As you can see, the assembly line, the concept of assembly lines given by Ford the first time, which revolutionized the whole concept of manufacturing and its related industries. So you can see a lot of people there working on a car, assembling things. There is an electrical conveyor moving down, and from that, some almost 90, 100 years back to this time where you can see only robots working in the line side. So you can scale the extent of human evolution in that, which the work has been done by hundreds of people. Now is maybe a single or two person can code the robots and make the similar work out of it. So that is the scale we are talking about here. And then we can see 1969 with the advent of electronics, when after World War II there is a lot of advancement happened in the field of automation, and people want better manufacturing facility, quicker products, and they want to reduce the wastage. So the mass industries came into the limelight, and then we can see it, and to operate such industries on that global scale, we have electrical applications like PLC and other IT solutions for it. So from 69, there is we are controlling mechanical device electronically, Until then, the PLC systems and other relay system has been replaced by coding. We have logical softwares and whatnot. So till now, Industry 3.0 is prevailing everywhere. Wherever any industry you visit, you will see the systems which has already been laid out. So that, but now, as again in the 21st century, the human aspiration grows. We are standing on the cusp of getting into Industry 4.0. So in our session we'll be discussing what is Industry 3.0 and where we are actually, and with our industry which we can see right now, in which current state they are working, and what it will take to take this advancement to the next level, which we collectively called as Industry 4.0. So our whole session will take a very simple case study, very simple. But even this simple case study will get progressively complex when you move one step towards automation. Let's imagine an Amazon warehouse. Uh, we can see a lot of parcels moving here and there. Mostly all are like square boxes. So it's easy to identify. There are no complex structures, just square or rectangular boxes of different weight, different sizes, and etc. And just you can see in the image a simple conveyor, a sorting conveyor. We can sort, right, where this parcel will go, for what is its destination, whether it is a fragile material or normal material, and about the weight, size, and everything we can sort as per our wish. By looking at it, we can see it's a simple conveyor. But from an engineering perspective, if you see, we can see a lot of things hidden in the plain sight. First is we can see vision camera. The camera is there, is embedded in every in every conveyor. You can see for what, to scan it, to scan the QR code or barcode, whatever it is, to know about what is there in the product. So product identification will be fed in the camera. So from the camera, we'll get the idea of what the product is. Then we have proximity sensor, which could sense whether the box, whether there's something available in the conveyor or not. So say proximity sensor is like, we able to get to know whether the box is, the location of the box. Then we have load cell conveyor. This load cell conveyor means below the conveyor there will be load cell transducers, which could give us the idea of how the box weights. So from the physical attributes like weight, size, location, we convert it into a digital form with the help of vision camera, proximity sensor, load conveyor, and we also have push transducer, so that the if the signal is right, we can push the box to that particular conveyor with whether the parcel is destined to go. So as you can see, all the physical parameters has been converted to a digital form, and an engineer who is working behind the screen would able to access all the data to make sure whatever the work is happening correctly. So in the plain side, it's a simple conveyor which can also be done by a human, but keeping the sheer scale of things, as you can see in the left image, there are so many parcels. It's impossible if you want to hire humans to do all this work. It will take a lot of manpower and a lot of time. So to save time and energy, and also cost and waste, we'll able to implement all this our apparatus, industrial apparatus, to get access of the data. So we have pick and place sorting, we have vision, weight measurement, QR code, etc. So this is our basic device which could give us inputs. But what we will do with the input? Well, so we got the data. Okay, this is the parcel. So what we will do? So what we will do, how the electrical mechanical systems will prevail, how the sensor should work. It will be coding uh, in PLC. I have been communicated like we all from instrumentation engineering, so I hope we will be knowing that PLC, programmable logic controller, uh, a little bit of it, if not more. So I'm not going into the details of the technicalities. I hope, but if there is doubt, please put there in the message. I will definitely uh, try to address it. Um, Yeah, so you can see there are lot of things going in the background also, and just keep this simple conveyor in mind. So as we proceed further, we'll be adding more things here. Like we already add here some sensors and all. We'll be adding more things in there, and we'll try to understand the advent of industrial automation currently, which is happening around us. Uh, so as an engineer, we all know our machines well. We all know we are very technically strong. We know which apparatus to add where and what result it will get, and lot of things we could able to do do that. We are all are involved in projects, and all these things excites us, right? The technology and all everything. But from project point of view, yes, technology is everything. But when we want to implement it on the real life basis, we usually the managers historically has faced this some problem, uh, which is experts of the industry has termed as 3R problem. So it is basically role, rules, and relationship, as you can see. But what the gist of it is, does your automation creates ambiguity in the role of a manpower, or will it disrupt the relationship of the manpower working with you, like in the line side, in the production lines, or everywhere? So we have to think from that perspective as well. So as an engineer, when you go in the into any industry, any factory, any corporate, so you have to think on that lines also. So, like one sentence is there, the rate of automation should match with human aspiration to evolve. So that has quite a deep meaning if you think that. So any level of automation should not disrupt human harmony in any way possible. Uh, so as an engineer, it's very important with technology, you have to take care of human problem as well. When you're planning for a project, you're planning for an upgradation, planning for an automation. So historically, has people has done that. So actually, there are two ways to do it. There are multiple ways, but broadly, if you study how the industry has progressed, we you can see the one is the Ford way, Ford Motor Company, which has implemented first assembly line, and then one is the Toyota way, which comes later into the scene of manufacturing. But since it entered, it dominated the principles of manufacturing like no other company. So we'll have some brief introduction about this. So Toyota way is very simple. We should have continuous running of lines. Like we can see the first assembly line given by Toyota. So their principle revolves around that, and the line should be interchangeable. Like many kind of products could be made in single line, and the division of labor should be constant. Means it should be very clear. The role of a manager, a role and responsibility of the person working should be very clear. And of course, the waste we have to reduce. So this is the four very fundamental and very basic principle the Ford has given, which I think it's very obvious. If you are in a factory as an engineer with all the technical knowledge you have, you will definitely try to reduce the waste. You will definitely try to install such systems which could give you the option to make your line more continuous, more reliable, and it's very basic. Then the Toyota way came, and it revolutionized the complete industry understanding of how things work. The Toyota basically what it proposes a set of rules. There are many set of rules they proposed, and collectively it is called TPS, Toyota Production Systems. So in the TPS, it basically addressed this 3R problem. Like automation, you can definitely automate. We can definitely automate. We can install sensors, transducers, whatnot, and automate full lines every line. But what problem it will create with the people working there? So that TPS model addresses that. So that's why it develops a balance between the automation and human aspirations from an industry point of view. So that's why now the TPS is way more acceptable, adoptable, and famous as compared to, you can say, the Toyota. Then there are some other things also. This TPS has given us. We have one Kanban card, and we have some Kaizen concept. We have just-in-time concept. So all these things, please note it down. Just keep in your memory. If you have some time leisure time, please do study about it. You will get to know more about how any industry will work, because now as the it became an industry standard, any even a small or big industry manufacturing any kind of manufacturing, say car, FMCG or whatnot, it more or less apply all these principles, maybe under different names. Maybe they have their own set of names which they follow, but the gist of the principle is almost the same. So which brings us to the concept of lean manufacturing, and as an instrumentation background engineers like you, this lean manufacturing systems is particularly very important to understand, because you will be designing the systems of any plant if you really want to go in a factory and be associated with it. So the lean manufacturing principle states all these TPS things and other things, how to do the things in a way which could be optimum for the industry. So at that point of time, once you form your theories, the implementation of technology will be very clear in your mind. So the gist of it, like as a budding engineer, we have to see a lot of aspect of engineering. Just not engineering, it involves human relation also. It involves some industry standard principle also, and if we follow, if you know beforehand all this, I think that will be a lot of help when for the day when you actually join the industry and start working there. So till there, if you have any doubt, just raise your hand. I will happy to address it. And if you have any questions or suggestions also, you can please ask. I'll be happy to uh, answer that. Or we can do this Q&A session at the end. Just please note down whatever query you are getting in the presentation, right? So shall we move forward? I think I take it as a yes. Okay. Okay. So let's talk about the factory automation as is, like what the current factory scenarios we are facing. So this is a very typical process of a factory where vendors will bring a part, and the part will be dispatched to factory, then the part will be received and assembly happen in the production line. As you can see this pictorically. So what are the points here? Because please remember this slide. We'll come back to this slide when you study all the automation process, and then we'll address this same slide from a different point of view. Like what are the things we could do to automate it. So as you can see, there are a lot of manual checkings available. We have manual data management, then we have system entry, but it has been done by human only. So more or less, the process is right now it is manually happening. So one part which comes from vendor has been stored in the factory. That part has to be uh, identified and has to be taken account, which is done by a person. That part has to put into the storage, because maybe the assembly demand is after 2 days. So that is again done by a person. Then in assembly line, to move that part from storage to assembly, at all every step has an human intervention, which is the current industry standard we are having. So what can be done about it? So we are talking about automation, and as you can see, there is very less automation available. So that question arises: what can be done? So so here we can see we can create a system where we'll move little bit towards automation and all. So how we do it? So here in the slide we can see a part which is receiving. So first of all, as just remember the conveyor, initial conveyor we're talking about, it's a simple conveyor with just boxes only, right? So we have some sensors there. So with that sensors, we can see here we have sensors and signal which forms the bottom of the pyramid. So all of these sensors we have uh, proximity sensor, we have vision cameras, we have servo motors, we have laser ID, temperature sensors, pressure sensors, uh, and all the type of sensor which is applicable in the industry. So this is the bottom of the pyramid, which we know we have the information right now. as an engineer, you will study in the college, you study from your subject experts, and all this, which you have to remember till even after college, because this is the same thing you will be implementing if you join any industry. So sensors and signal forms the bottom layer. Then to control this, to make it work as we want, we'll use the PLC softwares, PLC systems, PLC servers. So suppose this, let's take an example of this industrial camera, and let's take an example of this part sequencing part. So in the part sequencing, we'll install a camera, and the camera will be taking photo of the part which is coming. Maybe the outside of the box, one sticker will be there, and the sticker some information will be there. So they will be taking constant photos of it, and this industrial camera will save all this thing. And as an engineer, you will be able to access the data. So the question is how you will access. So the industrial camera will work as you commanded it to be, and it is interfaced with a PLC, and PLC will save the data in a hardware. Maybe it a local hardware, maybe the hardware will be present in line side only. Simple hard disk, it will save. Okay, so so in every step you can see here, from the vendor to the transportation to the factory to the assembly to the production line, lot of data are generating every second, because it's just not a one part. There are millions of parts, if not thousand, there are millions. So the millions data points constantly collecting lot of data from all possible sensors available. So so we have to manage it. We have to access it. So all the data are stored in the PLC, and from the PLC, if we want the data to retrieve, we can have a one supervisory level human machine interface. It can be an handheld device like a tab, or a kind of a joystick also in case of robots. If robots are operating, you can see in the pic here. And and from your office also, you could able to access all this data if it is connected. So now you can see in every points, vendor, dispatch, factory, part sequencing, assembly, production line, the data are generating locally. Vendor data is with vendor, part dispatch data with that truck or that transportation person. Factory data remains in the factory itself. So now the data is more or less very localized, but it is there, and just we have to go and fetch it. So one way of going and fetching it, you go to that point, you from your office, you go there, you connect your system with the PLC, you extract the data, you come to office, you analyze it, and you make a report out of it. Ki, okay, this and this is happening. Another step will be, we can implement a umbrella software which could take data from each and every part and store it in a single framework. So which is nothing but manufacturing enterprise system. So MES we will call it. So all the manufacturing data, even a single, uh, just imagine that conveyor. In that conveyor, one parcel was scanning one photo, so that photo will be stored. Like that, many conveyors will be there. So in some n number of conveyor, some n number of parcels data will be stored in MES. And if you want to access that, so suppose a customer will complain, where is my parcel? So you can immediately access it from your PC, and you can just convey the information to whichever department is asking for it. So that is the ease of working, which we can get from this umbrella kind of system, which we call manufacturing enterprise system. So right now in the industries, we can see a lot of MES, which could taking more and more data every minute, and there are many operations which are still which are still done manually, and the whole industry push is to automate all these operations phase wise. So the now the continuous improvement work is continuously going on to make the system to feed data to MES and to save it. The saving of the data will provide us many aspects in case of if in case of anything happened, in case of you want to backtrace it, so it will be very easy for an engineer like you to get the data and provide a solution. So that's it. So finally, above it, it is enterprise resource planning. So you are getting all the data in MES, but MES is manufacturing enterprise system. It is only related to manufacturing. In an industry, there are so many aspects. There are vendor expert, vendor vertical. There are a human resource vertical, there are quality verticals. So all these verticals, manufacturing is one vertical. So in any industry, we'll easily find 10 plus verticals parallelly working with each other. One is finance vertical, how the payments has been done, whatever part you receive. So all this vertical has their own data points and their own enterprise system. So we can call it financial enterprise system, we can call it vendor enterprise system, and many like same enterprise system can be many. So all this system will come together and feed their data to enterprise resource plan, which will be accessible from the company's management level. So the overall picture of the company will we can see from the ERP screens, which is again easily available for the employees to monitor their production lines and other things. So our journey starts from an engineer where we are technically strong from the point of view of the sensors and signals, and the real world condition we see and will implement our knowledge uh, to uh, to make sure to automate the process. And from that we'll keep stepping upon the pyramid, and we'll reach till the ERP management level where we can sit and analyze the data, and as our experience technically and with our technical experience we can see if there is some discrepancy in data or not. The whole point of all this is to remove any wastage if it's happening, is to remove any to identify the breakdowns if it happens, and any human error possible which could happen possibly to eliminate. So that is the complete ecosystem of industry which is now running like this. Uh, Again, please, if you have any doubt, please raise your voice, raise your hand, and if you want, you can type in message also. And if you want to share anything with me, if you have visited any industry and you saw something, that also, if you can share here, I'll be happy to listen to you. Okay, I think we'll take the question and answer at the end of the session only. Okay. I, uh, I hope these things will be clear to you, the system and all. Yeah. So let's get into some interesting aspects of factory automation, which is robots. Uh, it is not new for you. You must be watching a lot of commercial or studying a lot of things which you can see the industry, which has a lot of robots working on, especially particularly in car industry. We have body assembly lines, which there are some 400, 500 robots keep on running with non-stop, and for the multiple applications actually. And we can imagine our example also of the simple conveyor. Like in the simple conveyor, let me go back to slides and we'll discuss it. We can see the simple conveyor, right? We have 3, 4 sensors and all other systems running in the background. So how about I'll remove all this and put a robot here. So the robot will do all this work together, and we I don't need different sensors to interface each other and to make it a foolproof. I can just install a robot and code it, right? The robot will have a camera, it will take the photo. The robot will sense also whether the part is there or not. The robot will pick the part and check how heavy the part is, and the robot will place the part uh, to an suitable conveyor where this parcel we want to keep. So we can see, right, from an industry 3.0 we can jump to more automation level. Need not necessarily we call it 4.0, but yeah, the level of automation we can definitely increase with the existing industrial options we have. So in that case, we have our robot here. So we have leading robot manufacturing companies like ABB and Fanuc. They had their service centers in India, and they are providing like almost all industry there. And then we have Hyundai robots also, which our in-house robot we are using in our factories. So the basic functions they are doing is very intricate functions which require accuracy of microns. Like welding operations, we have sealer operations, scanning to check the body of the car, whether it is within all the coordinates are within the permissible tolerance limit or not. VIN number marking, vehicle identification number, and painting. Of course, the painting is a very critical task. Actually, it very difficult to do by hands because now the uh, because the surface is not smooth, it is curved, as you can see. The more and more cars, the design language is changing. It is not Model T, Ford Model T anymore. It's becoming more complex with different kind of surfaces. And material handling, pick and place, as I said, that is the very basic function of robot, which they will do inspection and other activities also. So here you can see, if as an engineer you have an option and you have given a project to automate a process. So first you will think on the lines of all the sensors, all the electromechanical devices, transducers we could think of, and the systems to operate that, like PLC and other software to interface everything. Then one option also available is kind of install this kind of robots which would do human operations. But again, the complexity of robots will be much more than sensors, because even if we implement sensor, there will be some human intervention which could help in case of in case of anything happen, anything goes wrong. But if we're automating the process with the robots, two or more robots, the level of coding, the level of real life scenarios you have to code it, the complexity level definitely increases. In the college, if you are learning any language, definitely in the school and all, I think you all are familiar with C and other stuff. And even in college, if you are familiar with any basic knowledge, say R or Python or C, uh, it will become relatively easy to understand the coding language of this automation appliances, such as robot and other things. It is not very difficult, uh, but yes, we have to code. We have to think as an engineer. We have to think the real life scenarios, what could possibly go wrong, and from that we have to implement many fail safes in our robot operations, and then in the industry wise, this practice is very common to do. So as you can see, the sealer application, paint application. In the right hand side, the diagram, you can see the robot reach, that curve you can see, right? It is the reach of the robot. So the reach of the robot has to be barricaded for the safety norms, and whatever our operation we are doing, we have to design based on this reach only. So a lot of consideration is there in the application of robot. I'll just show you the screen where we could able to code it. So here you can see is a software which is provided by ABB company, whose robot we are using. So the coding language is also this, and as you can see, it is not very different from R or C. Just the commands we have to get, and you can see this thing in the between. Is it a teaching pendant? So in the real life, there will be actual joystick we will be holding, and we'll be giving the command to the robot, just like we play the video game. Actually, this is the best example I could come up. Just like we play the video game, we'll give the command to robot. There is no other thing. But the thing is, the point to thing is the precision. The precision has to be in micrometers, because if the precision is gone even a point 0.1 mm, uh, there will be a chance of physical damage to robot or its surrounding. It is there. So you can see the program is, you can't see here, the program is pretty long. Actually, it's some 4,000 uh, long line, and then lot of modules we have to add it. Those who are familiar with coding, they could understand easily. Like fail-safe modules. What if any person comes while the robot is working? The robot should stop there immediately. So for the person should not come near the robot. For that, what we have to implement? We have to implement proximity sensors nearby in the floor, so that if any person unknowingly crosses the proximity sensor, the sensor will send a signal to robot, and we have to program that sensor's input. Like if the sensor's input is on, the robot should stop immediately to save the to safeguard the human and the machine. So like that, in the real life scenario, many conditions will come. And as an engineer, you have to think like now. Actually, the now right now they are providing the softwares, but previously, like 3 4 years before, we have to go to line side and actually simulate the conditions in the real time. So that is definitely time taking. But now, as the advancement of technology, they're able to provide the software, and in the seat, with your office itself, we would able to simulate the all the practical possible scenarios. So that's how you can see the increment in the level of automation is gradual, and the gradually with each and every process, the industries are trying to automate it, make it more foolproof, make it error free, make it fast, because the market demand, the demand from the customer is ever changing. Everybody want new things every year, not in every year, I mean in every quarter we want something new. So so to keep the matching demand, so all industry is poised to shift towards more automation, more precision, and less wastage in the process. So till now we are dealing with sensors and signals, different signals we saw. We are also familiar with a few of them, I believe. Then we saw some robots which we'll be using. Now we'll be talking about data collection techniques. Like in the slide we discussed, there are a lot of data which is keep on storing in PLC with all the sensors data, which is keep on storing in PLC, and with the help of HMI we can able to see, but it is localized. You have to go to this line side, to this, maybe to this assembly plant, maybe to this factory plant to go and see. But with MES we can able to see from our office itself what is happening. So, in addition to that, this is some steps we are doing to collect the PLC data. So, this is of a big machine, heavy machines, which aim is to provide to cut one part. This cannot be necessarily machine. It could be any sensor, or it could be any real-time manual input also. But for example's sake, I took this machine. So you can see in the left-hand side, equipment part is a numeric control based machine which have a lot of data it's generating every minute. Spindle speed, travel shaft, all this mechanical, electromechanical data we have. Then we have cooling system, hydraulic system, electrical system. All this, I think there will be more than 100, 150 points of data it is generating. So it is keep on generating the data, and we have to store some selected data. Every data I don't want. I don't want every minute hydraulic conditions or coolant conditions. I don't want every minute battery status. Yeah, a daily one time I want. So we have to decide as an engineer what data we want and what data we want to save it. Suppose we have finalized, for an example, we have finalized this four kind of data, as we can see: feed, RPM, spec, and cycle, which is now which is the only four data we want. So what we will do, we will try to collect the data from PLC, and once we collect the data, we'll collect with the help of softwares. We'll have like I said, MES software and other software I'll discuss just now. Just for the time being, we'll just see the PLC data we collected, and we will store it somewhere. And similarly, quality data also we can take. Like if I am producing a part, it should be whatever the quality I it intend to be. Some keywords here you will be watching, like SPC and all. It is nothing but statistical process control. It's simple. What we study in colleges, the principles of upper limit, lower limit, it is the same. Uh, but all these things are in the digitalized form. We would able to store it. So once this equipment and quality data we able to store in PLC, we'll transfer this data to our MES software. And how to transfer it, then we will have a software like MT-Link and IRIs. Actually every industry has its own set of proprietary softwares. So maybe if you go to Maruti, they have some different. Maybe you come to Hyundai, that will be some different. So it depends. But the functioning, the principle behind it is the same: to collect data from big machines, to save it, to store it, and to make it available for engineers like us to see and analyze. And if there is some problem, we would able to come up with solution. So this slide is the summary of what we are talking till now. Uh, till now we saw this pyramid, and this is the actual working of the pyramid. You can see this equipment level, lot of data is generating: panel, PLC, NC data, everything is there. And this data has to be transferred to our integrated management system, that is ERP. And in between we have MES, the same as the pyramid, it's just an elaborate form. So we can see we can save this local data from via wireless or by wire to a server. Earlier it was wired. We all have long IT connections across running across the industry. Now gradually we are converting all this wire to wireless. So we can see how the level of automation is increasing, but along with that, complexity also increasing. And from the wireless system, we'll send this system to our manufacturing enterprise software, and from the software, we'll send it to our ERP, which will store our manufacturing data and other data also. Uh, so this is the gist of what actually the level of automation in the factory is now currently, and what is the level of future automation is under progress now. So we are gradually converting all the wired connection to wireless, all gradually connecting all the machines, all the CNCs and NC machine with our server. So what will happen at one point of time when we're able to do that? Sitting in the office, we could able to monitor the real time running condition. Like if suddenly I have a change in production plan and I want to manufacture some other thing, I can see the data of our machine, the health of the machine, and I can easily make a plan to implement any kind of changes, uh, which earlier would have taken a long amount of time because I have to go to the line side and check and everything. So ultimately, the aim is to save time, to save money, and definitely to ease the work of the people who are involved in the line side, to work in the office and everywhere. So all these three aspects we should discuss earlier: automation with human aspirations. So to strike the balance between both is the utmost a priority for an engineer. Um, Okay, I think so. This is Industry 3.0 as is means this is happening right now around you. If you go, if you stand, if you get a chance for industrial visit and all, please go to any manufacturing line. Just stand there for 5 minutes and try to identify five things which you think it should be upgraded or changed, or five flaws which you could find in the current line, and that will give you a lot of insight of what we all what I shared you with now, like what we are discussing from last half an hour. So with that, with I hope you now have a clear picture in the mind of our industry systems right now. So keeping that in mind, we'll switch to what it will be. Current systems we have, it is there, and what is the next system? What is the next step we can do? So you know how the data has been collected, you know how the data has been generated, but now the next step will be what to do with all this data. So one thing we can do is we can analyze the data. So we can analyze, we can fetch, we can visualize. For that, we need all the data management techniques. As you can see, some softwares like Tableau and Power BI for visualization. Some data you are repeatedly getting from the line side, from your sensors which you installed, or sensors monitoring data, whether what is the health of the sensor which you installed, or to the health of the line you are in charge of. So we can see and visualize. Then some suppose you want to create we want to create a small program, and we can feed the program into the PLC to fetch any particular kind of data. Suppose temperature you want to know, and temperature module is not, so definitely you will be code something in PLC, or or the software, or maybe in the robot also. So for that you need basic coding in Python and R, and which also comes under the ambit of machine learning little bit. So gradually our industries are moving from uh, tailor-made modules to self-reliance in-house softwares. So that process is also started in a way. So many process earlier which we are dependent on industry industry suppliers, now we are doing in-house. Simple example is the robot which you saw, the robot programming and all. Now it's happening in-house. So with all this thing, the concept will come of big data. So Hadoop is a software which helps to analyze the big data, and Kafka is a software which helps to fetch the big data. So as you know, the data is stored in MES. MES servers has all the data. How you how you fetch it? And fetch means it's not like every data you want. You want a particular set of things which is relatable to you. So like we discussed here, there are 100 points the machine is generating, but only four things you need. So how you take only four, and how you neglect other 96? So that is an all. We have softwares in place. We have in-house. We have open source softwares where you can enhance your skill and really make a program which could implement in the real world, and which serves the purpose. So with this, we can have this predictive analysis also, like the machine health, your just again go back to our simple conveyor line. So the parcel is keep on coming. So with some prediction, you could predict what the next parcel would be, and your robot, the robot which you installed there, would beforehand will you prepare for such kind of parcel. So that is kind of a very simple example I'm giving just for the understanding. So that is advanced predictive analysis. And then further next step would be prescriptive analysis. Suppose you will prescribe you prescribe your lines, like okay, your machine is about to fail, or your machine is about to give some error without giving error. You're predicting, you're prescribing it, so that the line should not stop at any cost. In the Ford model, you see, we saw the principle, right? The continuous running of the line. So that is the thumb rule of any industry. The line should not stop. And with all these features, all these data we have in hand, and all the tools which are having in hand, we could definitely make sure that even in the case of breakdown, we would predict it beforehand, and we could prescribe the solution even before the breakdown has been happened. So that is a kind of a step up in plant management, and that could only be possible with big data management, and that exactly what Industry 4.0 is trying to achieve, to make the machines connected, and to keep the line running, to reduce the wastage. Some more thing, then yeah, some IoT network expansion. Like I said before, we are gradually converting our hardware IT lines to the Wi-Fi system, to the IoT system with proper security protocols, so that the systems could not be hacked. So the process is already started. We are already stepping. We are already one or two step inside the Industry 4.0. So data analytics has already been started. We have a production system converting from manual to digitalized form. We have many points which you can take the data. So the process has already been started. Data visualization has already been started. So at the end, what is our uh, aim to achieve is, as you can see, connected factory. I would like to take you to part of this slide where you see the whole supply chain process. The supply chain process, in every process, you can see human intervention and lot of wastage, the scope of wastage. But with the Industry 4.0, what we're trying to achieve is to restrict all the wastage. We could have our systems, our sensors, our coding, our programs to be installed at every step. whether it's a transport, whether it's a generation, whether it's a movement, multi-factor analysis. We have IT/OT integration. We have logistics. We have energy monitoring, whether the consumption of our resources, our compressed air, our energy is optimum or not, and everything is connected from the Wi-Fi. Every machine is connected from the Wi-Fi and giving input to our MES system. And from MES, there are engineers like future engineers like you who would be able to find out the problem amid of all the data you got. You will find out the trend, you will find out the problem, you will do predictive analysis, you will do prescriptive analysis of all the things, and that in a true sense would be the industry 4.0. So in the process, there are certain things also which is slowly entering. One is we have talked a lot about data, but then again we have this AI and deep learning algorithms, which is still in the very nascent stage of application. But I'm sure next coming 3 to 5 years, industry will be opting more and more of this to identify the uh, processes labs, the processes gaps, and to make it more foolproof and robust. So with that, I think we reached at the end of almost at the end of the session. I hope you understand the current practices of the factory, and from current practices where you stand, what is our way forward. Uh, I would like to suggest some of the books which helped me to understand. I think it will definitely help you to understand more about the historical aspect and the future aspect of industry. One is Santro, the car that built the company. It is written by first president of Hyundai Motors India, BVR Subbu, and then there is one PhD thesis research paper of the machine that changed the world, which will give very good insight of the global angle of Ford versus Toyota production systems. And then we have Toyota way of lean leadership, which could give further more insight of how production plant or any production plant related, not necessarily related to car manufacturing, other manufacturing also, how it evolved and how it should be. So with that, I, I hope I'll able to I'll able to share something which you could take home and remember it when you join the industry, or you will try to be and you will be the leaders there. With that, thank you very much for your time. I'll glad if you ask me some question, and I'll glad I will able to answer your queries.
Yes, thank you for your presentation, sir. It was very useful and informative. I hope the participants might have get few knowledge from your talk. So let this be a beginning of your automation process, and we wish you to have a very good career for the students. So if any queries, you can put up in the chat box, or you can ask. If you have any queries to put forward to him, you can kindly ask him. Or if you need any information regarding the automation, you can also ask to him.
Yeah, students, you could ask anything, need not necessarily related to technical aspect, other aspect also. As an engineering student, I know a lot of. When I was there, I had a lot of questions. So I hope that this is the time.
Sir, okay, thank you. Any queries, pa? Okay,
Okay,
sir. Sir, shall
no,
we?
yeah, no issues. If they had any queries later on, also you please communicate to me. I'll connect with them via mail or via email.
Okay, sir. Okay, sir. Okay, you will give your my ID. I will post it in student group, sir.
Sure.
Okay. On behalf of our E&I department and on behalf of our management, I will thank for your accepting this opportunities and to give an valuable knowledge about this industry 3.0 and industry 3 4.0. It's very interesting and knowledgeable session, sir. Thank you so much.
Thanks a lot, madam. Thanks a lot for giving me opportunity to interact with all of the students. It's completely my pleasure actually. I feel very nice to see young people getting interest about technology and all.
Okay.
And thank you very much for giving me the opportunity.
Thank you, sir. Thank you so much.
Okay. So with that, I'll take the leave then. Uh, okay. Thanks a lot for your time.